Hi, this is Mrs. Ward, and I'm going to go over the second half of the 9.2 homework on ellipses, classwork on the ellipses. So we're going to begin. The first one is asking you to find the standard form of the equation of the ellipse, find the center, vertice, foci, and eccentricity of the ellipse, and then finally sketch the graph of the ellipse. So remember, we're going to have to complete the square. So in order to do that, I'm going to keep my x's together, my y's together. Anything that does not have an x or y is going to go over to the other side. So I'm going to have 36x squared plus 48x plus 9y squared minus 36y is equal to 43. In order to complete the square, whatever the coefficient is of the square term is what we have to factor out. So this one's different because I don't think we've ever done one like this before, where this 36 is what I'm going to have to factor out, but the 36 does not go into the 48 evenly. But that doesn't matter. I still have to factor out the 36. So I'm going to factor out 36, make it x squared. To find out what I put here, I'm going to take 48 and divide it by 36. And when I do that, I end up with 4/3. So this will be 4/3 x, and it's okay that that's a fraction. Plus here, I'm going to factor out 9. 9 will go into 36 evenly, so that'll be 4y. And then this is equal to 43. I haven't changed anything on the right side. Completing the squares, still the same process. Even though it's a fraction, it shouldn't bother me that much. I am going to take half of the middle term. So I'm going to take this over here. So I'm going to take half of 4/3. So I'm going to do half of that. Or if you're a fraction person, you're thinking about multiplying it by 1/2. However you think about it, half of it will be 2/3. So 2/3 is what I'm going to put here. Oopsie, I put a squared sign there. That's not needed. So this will be 2/3. 2/3, and then I'm squaring it. And then when I square 2/3, remember you square the numerator. So 2 times 2 is 4. You square the denominator. 3 times 3 is 9. So I get 4/9. So I've got to figure out what I added to the left side. I put a 4/9 here. So yes, I did add 4/9 there, but I really added 36 times 4/9. So on my calculator, however, I'm going to take 36 times 4/9 and realize that I added 16 to this side, which means I'm going to have to add 16 to this side. And I hope you've been yelling at me and saying, Mrs. Ward, that should have been negative. Put a negative sign there. And now I'm going to do the 9. And when I do the 9, here's the 9. Half of 4 is 2. So 4 divided by 2 gives me that 2. 2 squared is 4, so I put a 4 here. I'm really adding 9 times 4, so I really added 36 to this side, which means I add 36 to this side. When I add that whole right side, I end up with a sum of 9. Now, every single ellipse that we've talked about has always been set equal to 1. So to make this equal to 1, I'd have to divide everything by 9. So I'm dividing everything by 9. And when I do that, I'm going to end up with 4 times the quantity of x plus 2/3 squared plus y minus 2 is equal to 1. And before you start identifying your A, your B, your C, and all that stuff, you got to realize that these have to have coefficients of 1. So I need to take this 4 is a problem, I guess is the best way for me to say it. So I had to ask myself, what do I have to do to get rid of this 4? Well, it's being multiplied. So I would probably multiply by a 1/4. So if I multiply the top of my fraction by 1/4, I'm going to multiply the bottom of my fraction by 1/4. That means that these will be 1. This is over 1. So to write it a little bit neater, I'm going to end up with x plus 2/3, that quantity squared, all over 1/4. And it's okay to have a fraction within a fraction for conics, plus y minus 2 squared over 1 is equal to 1. And when I do this, now I can find my center because it's in the standard form. So that's part A, standard form. Then part B, I'm going to say my center is going to be whatever I'm subtracting from the x, which is a negative 2/3. And whatever I'm subtracting from the y, which will be 2. So my center is negative 2/3, 2. Now I have to find my vertices and my foci. So I have to identify which one's my A and which one's my B. The larger one in an ellipse is always the A. So if I'm looking at 1/4 and 1 is larger. So my A is going to be 1. My B, well, the square root of 1, which is 1. I skipped that step. B is going to be the square root of 1/4. Because remember, this is A squared and this is B squared. And the square root of 1/4 will be 1/2. So to name my vertices, this 1 goes with the y, which means my vertices are going to go up and down 1, which means my x-coordinate is going to stay the same. I'm going to add 1 to the 2 and get 3. My x-coordinate stays the same. Subtract 1, so 2 minus 1 will be 1, and this will be 1. So those are my major vertices, but if I'm sketching this, and I'm just going to go over here and do a rough sketch, let's make this kind of bigger because, well, the numbers are smaller. So my center is -2/3, +2. So there's my center. My A was 1, which means I'm going to go up 1 unit and down 1 unit. And I've named those vertices right here. To find out how wide my ellipse is, that's where I use my B. And it's going to be, I'm going to take plus or minus 1/2 to that -2/3. So -2/3 plus 1/2 would be -1/6. 2, that's a 6. And then -2/3 minus 1/2 would be -7/6. And that does in 2. So that would be here and here. And so my ellipse would go something like this. It would be nice if I went through the dots. And then the last thing I need is I need to find my foci, which means I need to find my C. So to find my C, the formula is C squared is equal to A squared minus B squared. So C squared, A squared is 1 minus B squared, which is 1/4. So C squared is equal to 3/4. Take the square root of both sides. I'm going to end up with the square root of 3/2. Because the square root of 3 is the square root of 3, the square root of 4 is 2. So to find my foci, remember my foci are going to be on the major axis, so they're going to go up and down. So my x-coordinate will stay the same from the center. So for to find my foci, my x-coordinate stays at -2/3, but my 1, or my 2, I'm going to take 2 and plus or minus the square root of 3/2. And I can't simplify it, so I'm going to leave it like that. I think I'm forgetting eccentricity. So I've sketched it. Find the center for O in eccentricity. Eccentricity is so simple. Eccentricity is just simply C over A. So C is the square root of 3/2. A is 1. So it'll just be the square root of 3/2. And that's my eccentricity. So a lot of information for number 22, but there's all the work. Going on to number 26. Now they want you to find the standard form of the equation of the ellipse with the given characteristics and the center at the origin. So I'm just doing a real rough sketch. They're telling me that the center is at the origin. My vertices are 0, 8, so 0, 8, 0, -8. My foci is 0, 4, 0, -4. So I know my ellipse does something like this. So I know that since I have the center, I'm not adding or subtracting anything from the x to the y, so I can just write x squared and y squared. I like to set it equal to 1. This y is going to be, the distance from here to here is going to be my a. Well, the distance between 0 and 8 is going to be 8. So this will be 8 squared. I'll just leave it like that for a second. This will be my b squared. So I do know the distance from here to here between my center and my foci is my c, and in this case c is equal to 4. So I'm going to use that formula that c squared is equal to a squared minus b squared. So 4 squared is going to equal 8 squared minus b squared. So 16 is going to equal 64 minus b squared. Subtract 64, so negative 48 is equal to negative b squared, and b squared is equal to 48. Now I could find the square root. I could, but I really don't need to. It wants just the formula, so that b squared is what's going to go in here. So I can write x squared over 48 plus y squared over 64 is equal to 1. And that's my equation. I'm done. If I found the square root of 48, and I found that as a decimal, and here I'm going to cheat and use a calculator real quick, and find the decimal of that, that gives me 6.9-ish, 6.98. I mean, so if I wanted to sketch this, I know I'd have to go 7 units to left, almost 7 units left, and almost 7 units left to draw my ellipse. But if I don't need to find it, I'm not going to bother finding it. All right, number 29, the vertices are 0, 5, and negative 5, and passes through the point 4, 2. Vertices, oh, bad line. 0, 5, 0, negative 5. So I know that the center has to be halfway in between there, so I know my center has to be there. So this will be x squared because I'm not subtracting anything, y squared because my center is 0, 0 because it has to be halfway between the vertices. So it's equal to 1. If they give me these as my vertices, that means that this has to be my a, which is 5. So this will be 5 squared. This b squared, I don't know. So right now I have x squared over b squared plus y squared over 25 is equal to 1. I don't have a foci, so I can't find my c, and I'm looking for b. So in order to help me finish writing this equation, I'm going to use this point that they give me, 4, 2. This is my x, this is my y. I'm going to substitute those into the equation. So this will be 4 squared over b squared plus 2 squared over 25 is equal to 1. So I'm going to have 16 over b squared plus 4 over 25 is equal to 1. I'm solving for b squared, so I'm going to subtract 4/25 from both sides. And when I do that, I get 16 over b squared is equal to 21 over 25. Probably the best way for me to solve this would be to cross multiply. So I'm going to cross multiply. And when I do that, I'm going to get 400 is equal to 21 times b squared. Solving for b squared, divide both sides by 21. And so b squared is equal to 400 over 21. So I'm going to go back up here, maybe. And I'm going to put that in right here. So I'm going to have x squared over 400 divided by 21 plus y squared over 25 is equal to 1. And that's the standard form of the equation, and I am done. Going on to the next one. Wants me to write the standard form of the equation of ellipse with the given characteristics. So it gives me the foci, and I like to draw a picture. The foci is 0, 0, and 0, 8. Well, before I go any further, if this is a foci and this is a foci, I know the center has to be halfway between those two. So halfway between those two is the center. So I know that the center, oh, I did that wrong. My bad. Oh, rewind. I did the most common mistake you guys do. Oh, my bad. So when I go to do this, 0, 8 is actually not to the left or the right, but you go up 8. Oh, so much better. And now my center is going to be halfway between those two. So my center is going to be 0, 4. And then, knowing nothing else, I can write x squared over some number plus y minus 4 squared over, well, this is going to be my a squared because that's where the foci are. So this would have to be b squared is equal to 1. Now it tells me the major axis has a length of 36. That means from here to here is 30, well, from here to here is 36, which means from the center to one of those vertices is going to be half that. So I'm going to take 36 and divide that by 2, and I'm going to get 18. So my A is going to be 18. So this will be y minus 4 squared over 18 squared is equal to 1, x squared over b squared. So now to find b squared, I have my A is 18. My B, I don't know. My C is the distance from my center to my foci, which is going to be 8. So I'm going to say C squared, so that's going to be, we'll switch colors here. C squared, which is going to be 8 squared, is equal to A squared, which is 18 squared, minus B squared. So when I do this, 8 squared is 64. 18 squared is 324 minus b squared. So when I subtract 324 from both sides, this is actually negative, I get a negative 308. So b squared is equal to positive 308. And it should always be positive because a is always the largest one, so it has to be positive. So I'm going to have x squared over 308 plus y minus 4 squared over 324 is equal to 1. And that's this equation in standard form, and that's all they wanted me to give them. Okay, moving on to the next one. Okay, find the eccentricity of the ellipse. That's all I have to do is find the eccentricity. Remember, eccentricity is simply C over A. So I know my A is the square root of 9. So I know A is 3. So to find C, I'm going to use the formula C squared is equal to A squared minus B squared. So C squared is equal to 5, which means C is equal to the square root of 5. So the eccentricity of this ellipse will be C, which is the square root of 5, over A, which is 3. So just simply the square root of 5 over 3. 44. It wants me to find the eccentricity as well. So I have to complete the square to put it in standard form so I can identify my A and my B so I can find my C. So I'm going to say 4x squared minus 8x, putting all my x's together, plus 3y squared plus 18y, taking the 19 over the other side to get it out of the way for right now. Divide by 4, and I'm going to have x squared minus 2x. Factoring out of 3, I'm going to have y squared plus 6y. And still I have this negative 19. Completing the square, here's the 4. X minus half of 2 is 1. 1 squared is 1. So I'm going to put a 1 here. And then 4 times 1, which means I'm really adding 4 to both sides. So I'm going to put 4 there. And plus 3. Half of 6 is 3. 3 squared is 9. So I'm putting a 9 here, but I'm really adding 3 times 9, which is 27. And when I add that side, I get, what do I get? I get 12. Now, remember, these are always set equal to 0, so whatever number this is, that's what I'm dividing everything by. And when I do that, I'm going to have x minus 1 squared over 3 plus y plus 3 squared over 4 is equal to 1. Now, remember, we're trying to find eccentricity. So eccentricity is C over A. So right now I know my A is 2. So now I'm going to find my C. So I'm going to do C squared is equal to A. So C squared, so 16, oh no, 4. 4. A squared 4 minus b squared, which is 3. So I'm going to get c squared is equal to 1, which means c is equal to the square root of 1, which is 1. So c over a, I'm going to get an eccentricity of 1/2. Okay, the next one, I have a fireplace that is going to be constructed out of a semi-ellipse. So this is an ellipse, and then this would be the other half of the ellipse, but I'm only building the top part. The opening is to have a height of 2 feet at the center and a width of 6 feet along the base. And it wants to know the contractor draws the outline of the ellipse on the wall by using the method discussed on page 671. So what method is discussed on page 671 is where you take the string and you have it from a foci and a foci, and that string, those two together add up to the furthest part. So in order to do this, oh, actually my foci has to be down here somewhere. And they go like that. So the string, when I do this, the string has to, well, I know the length of the string has to be, it says give the required positions of the tacks and the length of the string. Well, the string has to be the distance from here to here. So I know that the length of the string has to be that 6 feet. It has to be, because if I put a tack here and put a tack here, wherever those are going to be, we're going to find them in a second, then they have to be able to stretch out. So they have to be 6 feet. So doing this, the tacks are actually going to be at the foci. So what I need to do is I need to find my C to find out where my foci is. So based on where the way this ellipse is drawn, my center is right here. So my center is going to be at the order pair 0, 0. So I'm going to have an x squared over some number plus y squared over some number is equal to 1. The x is going to be where the major vertex is, this 3 and -3. So the distance from the center to either one of these is 3. So this will be 3 squared here. I don't know what b squared is right now. So right now I have, so far, all I have is x squared over 9 plus y squared over b squared is equal to 1. I do have this ordered pair that's on the ellipse, and that's where the top of this arch or ellipse is going to be. So my x coordinate is 0, and they told me the height is going to be 2. So this is my x and this is my y. So I can substitute that in to my formula. And when I do that, hold on. So they did give me, if they give me this point here, this is going to be my minor vertex from here to here. From here to here. So that means that would be B. So B is 2. So B squared would be 4. So now I have x squared over 9 plus y squared, and this was a 2, so that's over 4, is equal to 1. To find my foci, I need to find my C. So C squared is equal to A squared, which is 9, minus B squared, which is 4. So I'm going to say C squared is equal to 5, which means C is equal to the square root of 5. So to find the places where I put these tacks, I'm going to go to left square root of 5. So negative square root of 5. My y coordinate would be 0. So these are my tacks. And then I'm going to go to the right square root of 5, 0. And then remember the string is 6 feet long. Moving on. Last one. So I have this comet. and it has an elliptical orbit, and I am going to cheat, and I am going to get an ellipse looking shape, and that's going to be the path of my comet here. And it tells me that the sun is one of the foci. So let's make this a little bit bigger, a little bit more like that, and I'm going to put the sun in there, and that's going to be, so I have a major axis C, and the sun is going to be on that major axis C, but it's not going to be at the center. It's not going to be one of the vertices. So if this is my major axis C, well, poorly drawn, then this is the sun. That's the sun. And here's my center somewhere. Let's make my center here. Okay. Now they're telling me that the orbit ranges from 0.34. So since this one's closer, we're going to make from here to here 0.34. From 0.34 to 4.08. So from here to here is 4.008. And then they want me to write a standard equation for the pathway of this comet. So, what do I know? I know a lot actually, but let's figure out what I know. I know from here to here is C. The distance from the center to the foci is C. I know that from here to my major vertice, from the center to my major vertice, that length is A. So, if I look at this 4.08, that 4.08 is going to be A, right, plus C. So A plus C is equal to that 4.08. Looking at the other side, from here to here is A. From here to here is C. So if I take that A and I take away that C, I'm left with that 0.34. So that A minus C is equal to 0.34. Well, that's a system of equations, a very easy, simple system of equations, because I can solve it by elimination, because the way I've written it, I can clearly see that the C's are going to drop out. And I'm going to say 2A is equal to, and then I'm going to get 4.42. And that should make sense to you, because from here to here, like the sun's in the middle. So the sun is going, it's covering the whole distance from one vertice to one vertice. Then these two distances together are covering the distance from one vertice to another vertice. Well, this is A and this is A. So 2A should equal the distance between those two vertices. So A ends up equaling 2.21. And so using this, I can substitute it back into either one, doesn't really matter. Let's say I take 2.21 minus C is equal to 0.34, and I get C is equal to 1.87. Then if I know my A and my C, I can use the formula C squared, so 1.87 squared is equal to A squared, so 2.21 squared minus B squared. When I do all that, I end up with B squared equaling 1.39 if I round it to 2 decimals. So writing my equation, I'm going to make the center at the origin x squared, y squared. It's going, my A is along as a horizontal travel, so this will be my A, which will go with my x, so this will be 2.21 squared, and then B squared, this is already squared, this 1.39, go to 1, so I end up with x squared over 4.88 plus y squared over 1.39 is equal to 1. And that is the last problem that we have on section B. If you have any questions, you feel free to email us, and hopefully it makes more sense. Talk to you later.